Alright, today our math video is on puzzle problems. It's from section 9.7. The puzzle problems are actually going to talk about three different things, three different types of problems. One of them is going to be a number problem or a digit problem. Another one is going to be an age problem, and another one is going to be a fraction style problem. So those three styles I'll be covering in the video today. Let's start with something like a number problem, which will be problem number 9 on page 447. Okay. Also, you may want to take a look at example 1 back on page 444. It'll use some of the similar terminology as I'm going to use in this problem here. So when we read problem number 9, it says when the digits of a two-digit number are reversed, the new number is 36 more than the original number. The units digit is twice the tens digit. What is the original number? Okay. So a couple important things to note when you're reading something like that is the number versus the digit. These mean very different things, and you need to make sure you understand the difference between them. If I write a number, now this has nothing to do with problem 9, so I'll just make a new page here. If I write a number, let's say 56, the 5 is in the tens place, okay? And the 6 is in the ones, which we are going to call the units place. The reason we're going to call it the units in this section is because we can use a u for the variable rather than using the word ones, in which case we'd want to use an O. But in math that looks like a 0. So units and ones are synonymous, so we're going to use the word units to represent the ones place. So when you say the number 56, the 5 actually has a value, if you remember expanded format back in like 6th grade, maybe 5th grade. The 5 actually has a value of 50. Okay, each digit has to be multiplied by 10 because it's in the tens place. The 6 has a value of 6 because it's in the ones place, so it's 6 times 1. So 50 times 10 plus 6 times 1 equals the number 56. So when you're thinking about the number, you have to think of it in expanded notation. So if I had the number 78, that 7 is worth 70, and the 8 is worth 8, so 78. Okay, so now let's get back and see how that applies to number 9. It says when the digits of a two-digit number are reversed. Okay, so they're asking us what is the number, okay, but they're talking about the digits. If it's a two-digit number, we have two digits here. We have a t, we're going to call the tens digit, and like I said before, the u is going to be the units digit. Okay, that being the case, we have to multiply the tens digit by 10 to get its value. So the original number would be 10 times t plus u equals original number. For instance, this isn't what the number is going to be like, but what if I said like 56 is the original number? Then it would be 10 times 5 plus 6 would be the original number. Now in this problem they're asking about the numbers being reversed. Okay, so in that case we'd want it to look like 65. So when you reverse the numbers, you're actually multiplying the units digit times 10 and then adding the tens. So this is the reversed number. Okay, so Now that we know what the number is, the original number and the reverse number, which are not 56 and 65, I don't think. That would be kind of random if I guessed that. Now let's go back and read the problem. So when the digits of a two-digit number are reversed, okay, so we're going to say that when they're reversed, so let's write that down. The new number, so that's the new number right here, let's write that. The new number, when they are reversed, the new number is 36 more than, so that's plus 36, it's 36 more than something, 36 more than the original, and that's back up here, that's 10t plus u, that's the original number, right? So we have then when the digits are reversed, the new number equals the original number plus 36. So that's one of our equations. The second equation says the unit's digit is twice the tens digit. Here they're not talking about numbers at all. They're talking about the digits. So remember back here when I said know the difference between when you're talking about the number and the digit. Okay? So that second sentence is talking about digits, and it can just be translated directly, and I'll write it in a new color. So here was equation 1. Now I'm going to write equation 2. The second equation is the unit's digit is twice the tens digit. Well, that's easy. The unit's digit is twice the tens digit. What is the original number? So now we have two equations, two variables, and we have three ways of solving it. We can use graphing, we can use substitution, or we can use elimination. Graphing usually is not going to be the right technique to go with, mainly because you can get a fractional answer and then you wouldn't know where it's at. Substitution looks really nice here because we're already solved for u. So into equation 1, I'm going to write 10 times 2t, because we're substituting in 2t for u, plus t equals 10t plus, still substituting again, 2t plus 36. So this is equation 1 rewritten without the u's, or replacing the u's with 2t to be more specific. I'm going to pause really quick here. So now we are at equation 1, and we're going to solve for t. So we're going to have 20t plus t equals 12t plus 36. I'm going to subtract 12t from both sides. Whoops. Okay, and I can combine this t right here. So subtracting 12t and adding those t's together will leave me with 13t and equaling 36. Is that right? Something doesn't seem right here. T 36. Alright, let's look at that again. So u equals 2t. So I got 10 times 2t plus t equals 10t plus 2t plus 36. Okay, so then we have 20t plus t equals 12t plus 36. Aha! Okay, so when I subtract 12t, I get 9t. That was the problem. And divide both sides by 9, I get t equals 4. 9, 18, 27, 36. Now if I plug that right into this equation, it's pretty easy to solve for u. So 2 times 4 is 8. So u is going to equal 8. So I think that the answer is 48 is the original. So I think the answer is 48 is the original number. Now I'm going to go back and read the problem. When the digits of a two-digit number are reversed, so they would reverse to be 84, the new number is 36 more than the original. So is that true? 36, let's see, 8, 14, that is true. Good. And the units digit, back to the original 48 here, the units digit is twice the tens digit. That's correct. So our number is 48, and we feel confident because we've checked it with the words of the problem. Okay, I'm going to pause this. We'll go on to the next video where we'll talk about an age problem.